In the last lesson, we saw that electrons are arranged in energy levels, but it turns out those electrons that are on the inner energy levels, they don't matter so much because they are blocked off. And so we have the nucleus in the middle with its protons and neutrons in there, and then we have energy levels around here. Well, electrons are very important because they're actually what are going to form bonds and change in chemical reactions. But if the inner energy level is surrounded by the next energy level, then these two electrons in here aren't really going to be able to form any bonds because they're blocked by this outer energy level here. And so we only really are concerned about in chemical reactions the outer energy levels and the electrons on the outer energy level. And those electrons get their own name. Those are called valence electrons. Okay? So valence electrons are electrons in the outer level. And like I mentioned in the previous video, that outer level is generally going to have somewhere between 1 and 8 electrons on it, and then the next energy level starts to fill. So the octet rule, which says electrons or atoms are stable when there's 8 valence electrons, applies to almost all atoms except the little ones. Okay, so the octet rule, octet just means 8. Octet rule, atoms are stable with 8 valence electrons. There's only a few exceptions to this, and that's for the smaller elements. Okay? So if I grab the periodic table, we have hydrogen and helium and lithium and beryllium and boron. Those first 5 elements, they only really want to fill the first energy level, right? The first energy level only holds 2. So small atoms up to boron are stable with 2 valence, or are stable with 2. Now, sometimes people will tell you that's the same as 0, and that's because of this. If we draw a boron atom, which is element number 5, so it has 5 electrons, we have our protons, so 5 protons, and say it's boron 10. And then it would also have 5 neutrons, and then our first energy level is going to hold 2 electrons, 1, 2, and our next energy level is going to hold 3 electrons. It can hold up to 8, but we only need 3 more to get to 5. So 1, 2, 3. Okay. Well, what this atom can actually do to become stable is give away these 3 electrons. And if it gives away those 3 electrons, then that energy level's gone, and so there's 0 electrons on the second energy level, but the first energy level has 2, which is full. So atoms are generally stable if they filled their outer energy level. Okay? So that's why the octet rule comes from, since most energy levels are full with 8 electrons on them. Most atoms are stable when they have 8 valence electrons. However, the smaller ones are stable with 2. Now, because valence electrons are so important, there's a shorthand way of drawing an electron dot diagram that just shows valence electrons. Okay? So an electron dot diagram uses a symbol and dots to represent atoms. And so we have to use the periodic table for this. Now, the periodic table is actually divided up into groups, which are these columns. Okay, so column 1, column 2, and then you'll notice this is the A group. I've mentioned this before. We're going to skip these ones in the middle. This is the B group sometimes. These are the transition metals. Yeah? We're going to ignore them for a little bit. So 1A is group 1A, and these have pretty reactive metals in it. 2A, fairly reactive metals, 3A some metals, 4A start to get some non-metals in here, 5, 6, 7, and 8A. Okay, so these groups actually are similar because they have the same number of valence electrons. Every element in group 1 has 1 valence electron. Every element in group 8 has 8 valence electrons, the exceptions being hydrogen and helium. Hydrogen does have 1 valence electron, helium only has 2 because it fills the first energy level. The reason the periodic table is also put into rows, and these rows are called periods, is because the new period starts when the new energy level starts filling up. So row 1 has an electron in the first energy level and the second electron in the energy level. And then row 2, we have the third electron, which is the first one in the second energy level. And these 8 elements fill the second energy level. And then we go to row 3, and you have electrons in the third energy level. Okay, so each row or period on the periodic table is for a new energy level. They're called periods because properties repeat in a period. The first element in a period is always a metal. The last element in a period is always a very stable non-metal, and they change from metals to non-metals as you move from left to right. So a column is similar because they have the same number of valence electrons. A row has changing properties because they have different numbers of valence electrons, and they actually increase by 1 from 1 to 8 as we move from left to right across the periodic table. Now, what that means is if we're looking at a periodic table, we can tell how many valence electrons something has just by looking at the A group column number. So if I pick phosphorus, say, phosphorus is right here. It has 15 protons, which means it also has 15 electrons, but because it's in column 5, or 5A, I know it has 5 valence electrons. So to draw a phosphorus, a representation of a phosphorus atom, what I do is I say, okay, well, phosphorus has 5 valence electrons, so I'm going to use its symbol, which is capital P, and I need 5 valence electrons. So I put a dot here, a dot here, a dot here, a dot here, and that gives me 4, and now I need 1 more, and that goes there. Now, I didn't do that randomly. Okay, so there are a couple rules here. Each side can have 2 dots. Okay, these dots, remember, are representing valence electrons. But no side gets 2 until all sides have 1. There's only one exception to this rule, and it's helium. Okay? Helium's electron dot diagram looks like this. And you can put the 2 dots on either side. It doesn't matter. They could be here, or we could have helium, and it could look like this. It doesn't matter where I put those 2 dots. But the reason helium is like that is because helium has only 1 energy level, and those 2 electrons fill it. Okay? Lithium is in the 2nd energy level, but it only has 1 valence electron. So if we were going to draw a lithium dot diagram, since it's in column 1, we would say lithium, Li, and we could put a dot on any side, and that tells me lithium has 1 valence electron. So when you're drawing electron dot diagrams, we're only worried about the number of valence electrons, and to get that, you look at the column number on the periodic table.